So welcome along to week 4 of computer programming, and topic 4 in fact. And this topic we're looking at some very simple programming concepts, and those are variables, types and operators. So let's dive in and have a look at these then. I'll just rearrange my screen a little bit. So the first thing is variables. Now this is a very easy concept. A variable is like a box in the computer's memory, and we can store things in there. And in order to store things in a variable, we use this thing here, and this thing here is called the assignment operator. Okay, the assignment operator. These things either side of the assignment operator are called operands. Okay, so we have operands either side of an operator, which is the equals sign. And variables, we have an identifier for them, and that's just called the variable name. The fancy name for it is the identifier. I just call it the variable's name. Okay, so if we want to try and develop something with some variables, let me just grab a new console and over here, and let me just, so here we have a console, and let's just close that off, and we want to try to assign some variables. So if I say average is equal to 5, and then I press Shift and enter, okay, we're going to enter the value average and store it with the identifier of 5. Now if I do print, okay, average, and then just return that, it's going to return the value of 5. So it's very straightforward. So we can do my number equals 10, okay, print, okay, my number plus average. See what happens here, 15. Okay, so we've stored the value of 10 and the value of 5 as a variable, and then we can print out that and add them together and get the result back. So as I said in week 1, remember, the computer can only do two things. It can perform a calculation and it can store the result. So those are the only two things that the computer can do. We get that, and once we get that into our mind, we realise that all we're doing is just performing calculations and storing results. And we can store these results. The most simple way we can store them is in this thing called a variable. And the reason it's called a variable is because it can change. Okay? Now in other languages, right, when you want to create a variable, you have to define the type of the variable. So in C#, for example, you would have to say string, my string equals hello. Okay, you have to actually say that it's a string. But in Python you don't have to say that it's a string. In Python you just assign it, and then Python, okay, Python knows, oh, I spelled print wrong, did I? P-R-I-N, print. Python knows that it's a string because it's in quotes, okay? Python just accepts that it's a string. And we can actually change the types when we want, and this is called dynamic typing. Okay, so in C#, for example, C# is a statically typed language, and Python is a dynamically typed language. And I'm going to show you an example of this dynamic typing now. Let's just clear the output here. So I'm going to create a variable called my test, right, equals, I'm going to put it in quotes, I'm going to put 5, and then I'm going to enter that. So now if we do print type my test, it's going to say that it's a string. If we now do my test equals 5 and we take away the quotes and enter it, and then we print the type, it's going to say that it's an integer. We've just changed the type, and that's called dynamic typing. Okay, it means you can change the type anytime you want. All right, it's different from a statically typed language where the type is fixed. Okay, so those are variables, and here's a little calculation I've made. Average equals grade 1 plus grade 2 divided by 2. So if you had 2 grades, we could store them in the computer's memory, and then we could make a new variable called average that was the total of those 2 grades divided by 2. Okay, right, so assigning variables, we do this with the equal sign, and the equal sign is called the assignment operator. Okay, and the things that we assign are called operands. Right, types. Okay, now I've made a funny graphic here. I don't know how amusing you're going to find this. You're probably going to think it's a terrible joke. But I found this graphic, types of dating, and I've replaced it with an A there, types of data. So Python understands different types of data. Okay. Now, the most common types, I'm just going to explain what those are now. The first one is an integer, and an integer is just a whole positive or negative number. The second one is called a float, okay, and that's just a number with a decimal point. Americans call the decimal point a floating point. Okay, it's American terminology. Then we have this type, Boolean. Okay, now Boolean just means true or false. Anything that's a Boolean is a true or false statement. So, I'll give you an example of each of these now. So let's just clear the output on this console, and let's go. So let's do an integer. So my variable equals 5. Okay. Then we're going to print type my variable, and it's going to return integer. Okay. Next one we're going to do my variable equals 5.0. The type is now a floating point number because it has a decimal point in it. Okay. And finally we're going to do my variable equals 5.0 in quotes. Going to return type my variable. It's going to say it's a string. We'll get to strings in a second. And then if I say let's turn it back into a number, so my variable equals 5, and if I say my variable is greater than 10, okay, so is 5 greater than 10? No, false. So that's a Boolean type. It's a test. Okay. If I say my variable is less than 10, is 5 less than 10? True. Yes, it is. So those are the different types that we have, data types. Now, it's important that we know what type we're working with, because whatever type we're working with, that's how Python's going to treat that variable, that object in the memory. It needs to know what type of object it's dealing with. Right. So strings can be anything. They can be numbers, decimal point, floating point numbers, words, sentences, any string of characters, as long as it's in quotes. Okay. Now you can use single quotes or double quotes. It doesn't matter. But there is a wee problem if you do, for example, so let's get back to the string, right? My variable equals, and let's do it like this, equals don't like Python. Okay, run it like that. So let's do print, right, my variable don't like Python. That's fine, but let's say we want to put an apostrophe in here to make that spelled correctly. Let's run that. It's going to give us a syntax error because it thinks that this is the end of the string because we started it with that. So in that case, it's better to use the double quotes around here. Okay, then it won't give us a syntax error. Alright, So that's the reason why we wouldn't use single quotes, because of that problem there, right? We need to put an apostrophe in the middle of it. It breaks the string. Okay, so the next part is operators. So we have these variables, objects in the computer's memory. We need to perform some operations on those variables. So some of these are really easy. Add just adds two values together. Subtract just subtracts two values. Multiply just multiplies two values. Now, when we say that we're going to multiply two values, that's called getting the product of the two values, okay? And these are some of the kind of fancy names. If you're adding two objects together, two variables together, they're actually called addands, the operands in an addition operation. Same with the subtraction's got a fancy name as well. Subtrahends are the operands in a subtraction operation. There are two types of division in Python. We have float division, which gives you it's just like normal division, float division, okay? And then we have floor division. And floor division rounds down to the nearest integer. Okay, so I'm going to give you an example of this now. So let's just clear the output on the console here.
Michael,
yes.
Sorry to interrupt. Do we need to remember the terminology of these things for the theoretical part of it?
I wouldn't worry about remembering things like subtrahends and things like that.
Yeah.
You just need to know how to use these, okay? You don't need to know that it's called an addand or anything like that.
Yeah, no, that's fine.
I'm just telling you the terminology because that's the actual name for it, okay? It's good to get names for things. If we don't get names for things in programming, then we end up just calling it, oh, you know that thing over there. So let's have a look at the different types of division. So let's set up a variable that we're going to divide. So we'll make it an easy one, right? Let's go division test equals 30. So we've got this value called division test stored in the computer's memory now, okay, as 30, okay? And if we want to check the type of that value, we can just pass it to the type function, and it'll say it's an integer. Now, let's do 30 divided by 5. Okay, 30 divided by 5 should give us 6, right? Let's hope. So let's run that. 6.0, because this thing here is float division. Okay, it always returns a float. Always returns a float. So let's do it with the double slash now. Let's do floor division, right? So divided by 5, floor division gives us an integer back. Now, that seems, you think, okay, right, fair enough. Let's look at something a bit more abstract. So let's do 30 divided by a number that doesn't divide evenly. So let me just try and think of one that's fairly straightforward. What about 30 divided by 4? That would give us, I think, 7.5. So let's do 30 divided by 4. Let's run this. 7.5. Now, that's all well and good if we're using float division, but if we use the floor division on that, it's going to return 7, okay? Because the floor division always rounds down to the nearest integer. Okay, you can think of it as rounding down to the floor, the division floor. I don't know why it's called floor division, okay, I didn't make up the name for it. So, floor division, the double slash will always round down, alright? And the single slash will give you division of a floating point number. It'll always return a float, okay? So this is, you could think this is more like real division, and this is like rounding down integer division, okay? Whole integer division. The last and probably most interesting operator is this thing, the modulus. And this returns the remainder after the division. Okay, so let's see. Let's set up another variable. So we'll call it modulus test, right? Modulus mod test. Let's go for that. Mod test is equal to 10. Okay. So let's print mod test. Let's just check the type. Mod test. Type is integer. Let's just check that mod test actually prints out. Let's see what we've got in there. Always check the type. It's 10. Good. That's what we expected. So let's do 10. Let's do mod test. Mod test. Okay. Modulus 2. So 10 divided by 2 is remainder question mark 0, because 10 evenly divides by 2. Okay, so let's do mod test modulus 3. So 10 divided by 3 is 3 remainder 1, so the answer should be 1. Okay, there we go. Alright, okay, so just try something just random. Let's see what. Let's go through them all. Let's do it without saving it as a variable. Let's do 10 modulus 1. 0. Okay? Because 10 divides by 1 into 10. 10 modulus 2. 0. Because 10 divides by 2 evenly as well. 10 modulus 3 gives us 1. Because there's a remainder of 1. 10 modulus 4 will give us 2, because 10 divided by 4 is 2, remainder 2. 10 modulus 5 is going to be 0, because 10 evenly divides by 5, no remainder. 10 modulus 6 gives us 4, because you only get 1 6 and then you got 4 left over. 10 modulus 7 gives us 3. 10 modulus 8 gives us 2. 10 modulus 9, you're not going to get any prizes for guessing, it's going to give us 1, because 9 remainder 1. So the modulus operator returns the remainder after the division. Now, modulus is very important in cryptography. It's used all the time in cryptography, alright, the modulus operator. So very important to understand the modulus operator. And just to go off a little bit on a tangent about the modulus operator, think about it this way. If I said to you that so time now, if I said to you, let's say it was 11 o'clock, and I said to you, I'll meet you in 48 hours. Immediately you think, okay, that means at 11 o'clock in 2 days. You don't think, oh, that means 11 plus 48 would be 58 plus 1, 59. I'm not going to meet you at 59 o'clock. I'm going to meet you at 11 o'clock because it wraps round. It wraps round at 24. It goes back to 0. Okay, so really, when we're talking about time of day, we're actually operating in mod 24. Okay, so I can show you this in Python now. So for example, it's 11 o'clock, right, and I'm going to meet you in 48 hours. Okay, so 11 mod 24. Okay, so let's say we're going 11, do it the other way around, 24 mod 11. I think I was right the first time. 11 mod 24 is 11. So I'll see you at 11 o'clock. I'll see you in 24 hours. Now, let's do something higher. 48 mod 24. It's going to give us 0. Because I'm going to see you in 48 hours. I'm going to see you at 11 o'clock. Okay? If I say 49 mod 24, it's going to give me 1. Okay? So, because I'm going to see you in 49 hours. Okay. Now, this can also be applied to days of the week. Days of the week, we're actually operating in mod 7. Okay, so let's do 1 mod 7. Okay, 1 mod 7 should give us 1. If I say I'll see you in one day, I'm going to see you tomorrow. Okay, which would be today's Wednesday, tomorrow's Thursday. So one day. Now if I said to you, I'll see you in 8 days, that's also going to be Thursday, isn't it? Because it wraps round at 7. Okay? So this is now, if you imagine, right, if I do something like, if I said to you a question now, right, given that we understand that mod 7 means divide by 7 and tell me what the remainder is, if I said to you, I'll see you in 49 days, 49 divides by 7 evenly. So that means that in 49 days, it'll be the same day as today. So if I said to you, what day will it be in 50 days, you would say Thursday, because it's 50 mod 7, isn't it? One day ahead. So if I said to you, what day will it be in 100 days, right? I'll tell you what day it'll be in 100 days. It'll be Friday, because 100, right? Well, you can do it quite quickly in your head. 100 divided by 7, we got 70 is 10 sevens. And that leaves us with 30. 30 divided by 7 is 4, remainder 2. So there's going to be a remainder of 2. So if I do 100 mod 7, 10 mod 7, 100 mod 7 gives us 2. Okay, so we'll be 2 days ahead then, because it wraps around. Now, the reason why this is important in cryptography is because these numbers are usually quite small. The answer in a modulus will also always be lower than the modulus itself. So the answer, anything mod 7, will always be 1, 2, 3, 4, 5 or 6. And the reason that's important is because you can get a number out. Like I can say to you, the answer is 3. And you could say, oh, well, that could be 10. Or it could be something else. Let's just see if we can get a couple of different 3s out. So we know 10 mod 7 gives us 3. Let's see what happens if we go 14 mod 7 will be even, 15 will give 1, 16 will give 2, 17 mod 7 gives us 3. Okay, so 17, let's say 23 mod 7. Oh, meant to do 23. Gives us 2, so 24 mod 7. So if I said to you the answer's 3 and the question is mod 7, it's very difficult to tell what the input value was, because it can be any number of things. It could be 375,422 mod 7 could still give us 3. Alright, and that is a way that we can create this thing called a trapdoor function, which means it's very difficult to tell how many times you've gone round the mod clock to get the answer out at the other end. Okay, so there's a little bit on modular arithmetic. Right, so an operators can be arithmetic, which I just talked about, doing calculations. They can be relational, sometimes called rational, and they can be logical, okay, which means like greater than or less than, okay? And an operator in a programming language is just a symbol that tells the interpreter to perform some calculation, okay? So some other examples: relational operators are just operators that compare things. So is it greater than or equal to, less than or equal to, not equal to, true, false. Sometimes these are called rational operators. Sometimes these are called, I think this is the best name for them, comparative operators, because you're comparing two things. You're saying, is this greater than this, or is it less than this? Okay. So if we run back to the console again and we do something like, is 5 greater than 5? No. Is 5 the same as 5? Yes. Is 5 not the same as 5? No. Is 5 less than 5? No. Is 5 More than 5? No. Alright, so it can do, is 5 more than 4? Yes. Is 5 less than 4? No. Is 5 not equal to 4? Yes. It's not. 5, yes, 5 is not equal to 4. Yes, 5 is no 4 equal. Okay, so these are just ways of comparing variables. I think these are quite straightforward. Then we have these membership operators, and we're going to look at those in more detail in the next chapter. Okay, so we need to know a little bit more Python before we can look at these. But we can say things like, is value in other value? And I'll explain that in more detail next week. Okay, and then assignment operators. We actually have some more intelligent assignment operators. As well as just equals, we can add an equal. Okay, so we can assign and add. We can subtract and add. We can multiply and add. And we'll look at those in more detail a little bit further into this course. This is just an introduction to some of the different operators that are available in Python. Okay, so a couple of examples. These are things that I've already shown you. So x, int 1, y, int 2. So this is called let's say we'll call this typecasting. Okay, so let's do y equals 5, and then let's do y equals int. Probably a bad example. Let's do y equals 5.0. So print type y, and that gives us float. Okay, so now if we do y equals, let me just check the syntax of this so I get it right. Y equals int brackets 5.0. Now print type y. It's changed to an int. Okay, so Python will just change the type when you tell it. You just say the type, send it to the type function, and it will just change it. Okay, so we can change it back. We do y equals float, print type, and now it's a float. Okay, so it'll just change when you want to change it. Some other examples, we've got some strings down here as well. We can change stuff to strings as well in that way. Data types. Okay. Right, last part today, a little bit of concatenation. So the add operator doesn't always just add. Okay, we can use it to join things together, and that's called concatenation. So let's do print, right? Now let's make a couple of variables. Hello equals a string called hello. World equals a string called world. Print hello plus world. Hello world. Okay, now let's say you're going to say that's a stupid word. It's not a word. So let's put some spaces in here. Okay, plus world. Let's just tidy that up as well. Hello. I think that'll work. Yeah. Hello plus space plus world. Okay, so that's called string concatenation. All right. So obviously you can't add the words hello and world together. Okay. So when you use the addition operator on a string, it joins the strings together. That's a little extra thing that it can do. Okay, so string concatenation. There's an example of some variables. So I'm just going to show you a quick program that I'll put together about scores. So let's say score 1 equals 50. Score 2 equals 30. Okay. Average score equals score 1 plus score 2. Okay. Let's go total score. total score equals score 1 plus score 2. Print total score gives us 80. Right, average score equals total score divided by 2. Alright, divided by 2. Okay. Print average score and that's going to give us 40.0 because we're using float division. Alright. Now we could have also done it like this. Average score equals total score times 0.5. Alright, that'll give us the half as well. Okay, so print average score, just that. And we could also use, because it's an even division, we could also use the floor division. Okay, and that'll return us an integer because it's even. But if the average score was not even, then that would be rounding down. Be a very unfair algorithm then, be an algorithmic bias in that algorithm. Okay, well, we've just got to a slide that says any questions, so this is a good time for questions. Anyone have any questions on those exciting topics? We have variables, types, and operators.
Yeah, while printing result, can you modify the type as well?
Oh, probably. That would not surprise me. Let's give it a wee shot.
When you print in 40, see.
Yeah, so let's check the type first of all. So let's do print type. Okay, and then average score. So let's validate the type first. So it's an integer. Now, if we do print float average score, it'll change the type. But let's do print. Can we do type float average score? Now we're getting confusing. Brackets, brackets, brackets. Okay, it's a float. Okay, so this is called nesting, right? We can just nest the functions inside each other. It's really straightforward. You should be able to. I didn't know whether that was going to work or not. I just made that up and just guessed. So this is the great thing about Python. Not the good thing. The great thing about Python is once you understand how to do a few basic operations, it's very, very, very easy to work with. It just makes sense. It just works quite well. Anyone else got any other questions about the exciting world of variables, types, and operators? Right, I've got a notebook for us. Let's have a look at this notebook now. Control B. Not Control B not working today. Yes, it is. Just need to press it harder. Control B. It's analog. Right. Level 7 Python. So we have a notebook on variables and types because that's today's topic. So let's just close that. Control B. So in the notebook today, I have an explanation of everything that I've just talked about in more detail. Also, if you're wondering why my notebook looks so much nicer than your notebook, I'll tell you. If you go to plugins, the extension manager, I found a good extension at the weekend, this solarized dark theme, and installed it. Alright, so just like how we installed Draw.io, you can install this solarized dark and then you can go settings, theme, and change it. So I used to use this theme called JL Dracula. Right, let's have a look at that. Now this is, don't get me wrong, this is a lovely theme. This is very clear, but for some reason I just like this solarized dark theme better. I don't know why. It's very easy on the eyes, this one. I was using it at the weekend and I like this is my new favourite thing. Now, to get some of these installed, alright, you might have to install Node.js on your machine. Okay, so that's something to think about. Another thing as well is, once you know how to write variables and assign variables in one language, you can very easily do it in another language. So, for example, let me just grab a new launcher here. Let's say we want to do this in JavaScript, right? So here we are in JavaScript. So in JavaScript, to assign a variable, we need to use the keyword let. So we just say let my variable equal 5. And in JavaScript, we always need to end the line with a semicolon. So let's just enter that. Now, if we do console.log space my underscore variable, always end with a semicolon. Oh, how did that not work? Let my variable equal 5. Unexpected identifier, console.log my variable. What have I done wrong?
You should use capital letters instead of your variable.
No, I don't think so. Unexpected identifier. Let my variable. Do you know I did this the other day and it worked? I don't know why. Like, let my variable equal 5. Oh, okay. My variable has already been declared. Now, this is useful. This is why we use let. Okay, it's safe. Console.log 5. Alright, so let's just pretend that that never happened. Let's just do hide this output. Console.log my variable 5. Okay, so that's the way we would do it in JavaScript. Now, you might think, oh, but we're not doing JavaScript. Oh, I've never used JavaScript before. Yes, you have. You're using JavaScript right now. You just don't know that you're using JavaScript right now. In your browser right now, if you press F12, okay, you will get a JavaScript editor. And see, if you click console, down here at the bottom, you can actually enter this stuff down here. So copy, down there, right, let my variable equal 5, okay, and then console.log my variable, paste that in there, returns 5 down here. Okay, so press F12, that'll take it away. There you go. So your web browser is actually already a JavaScript interpreter. You're already using JavaScript. You just don't realize it. Right, let's return to Python. So, variable assignments, data types, a little bit more of an explanation, and then there's some examples here, and then there's some questions in part 2. Okay, so what I would like you to do is I'm going to make this available to you, and I'd just like you to download it, answer the questions and upload them. These should be straightforward, okay? So for example, create and print the following variables. So that should be able to do that with your eyes closed, okay? Just create my number. I'll cover my eyes right now and I'll just lean over the keyboard, right? my underscore number space equals 5. Okay, I was close, alright? That's pretty good. I'm doing that with my eyes closed. Okay, so if I had a little bit more practice about feeling where the J, you know the little bump on the keyboard on J and F for blind people, if I had a little bit more practice, I'd pretty much doing that with my eyes closed. Okay, so that's how straightforward this actually is. Right, so I'm going to make that available to you. I'm going to stop the recording now because there's no more new information in week 2. And I'll probably leave that bit in as well where I messed up all the JavaScript because I think that's quite funny. So let's just